Welcome class 6. Today's topic is properties of whole numbers for multiplication. So for multiplication, the first property that we will follow is the closure property. As we have already learned about the closure property, that if the two numbers have a binary operation, whether it's addition, subtraction, multiplication or division, and the result obtained also lies within the given number set, then we say it's the closure property. So here the two numbers x and y are multiplied, and if the answer, the product obtained, is also a whole number, then we say the closure property is fulfilled. So here the example is 5 times 4. 5 is a whole number, 4 is another whole number. When you multiply 20 comes the product, okay, 20 is again a whole number. Similarly, 12 times 0, 12 and 0 both are whole numbers, and the result obtained is 0, which is again a whole number. 0, a whole number, multiplied with 23, a whole number again, then the result obtained is 0, which is a whole number. Similarly, 15 times 6 equals 90. 15, 6 and 90, all of these numbers are whole numbers. So when a whole number is multiplied with another whole number, the result obtained is also a whole number, then we say the closure property for multiplication in whole numbers is fulfilled. Property number 2, commutative property. Commutative is like if you multiply x and y and you obtain a result, and similarly if you replace x and y, if you change the places, you write y first and you then multiply it with x, again the result comes out to be the same one, then we say it's commutative property. Means whichever you put the number in front, then the result obtained is similar. Over here you can see 4 times 5 is also 20 and 5 times 4 equals 20. So 4 times 5 and 5 times 4 both are equal. So this is the example for commutative property. Similarly, you can see there are 3 more examples. 3 times 0 is 0. 0 times 3 is also 0. So commutative property is fulfilled. 8 times 12 is also 96. And 12 times 8 equals to 96 only. So here again the commutative property is fulfilled. So we can say that for whole numbers, commutative property is valid for multiplication. The third property is associative property. Associative means whether if you take 3 of the numbers and multiply the whole numbers, and whether you multiply the second and the third first, and you multiply the first number, or you multiply the first and the second number, then you multiply it with third, both will have the same result. So over here 4, 8 and 10 is taken. So 8 and 10 is multiplied first, the result is 80, and you multiply it with 4, then the result is 320. Now in the second case, you multiply 4 and 8 first, the result is 32, and you multiply it with 10, 32 times 10 is again 320. So in both the cases, the result is similar. Then we say that it's a associative property. So for whole numbers multiplication, associative property is always true or is always fulfilled. The next fourth one is called the distributive property. So over here you can see that x is getting multiplied with the sum of y and z. Okay, so you can expand it or distribute x over multiplication over here, like x times y plus x times z. So this is called the distribution or the distributive property. So here the value of x is taken as 5 and y is taken as 3 and z is taken as 4. So when 5 gets multiplied with 3 and 4, 3 plus 4, you can simply add 3 plus 4 as 7, and 5 times 7 is 35. Or you can just apply the distributive property, like 5 times 3 first and 5 times 4. Then 5 times 3 is 15 and 5 times 4 is 20. 15 plus 20 again gives you 35. So we can see over here that the distributive property for multiplication of whole numbers is again true or is fulfilled. In the same way, if you take more examples or more sets of values like x, y, and z, and every time prove the above results, verify the distributive property of multiplication over addition. And similarly, we can prove that the distributive property over subtraction is also true. So the multiplication of whole numbers is also distributive over their subtraction. So subtraction and addition, the multiplication of whole numbers over subtraction as well as addition remains true in case of whole numbers. Here another example is taken, application of distributive property. See over here, 15 times 135. You can split this 135 into numbers like 100 plus 30 plus 5. So 15 times 100 is 1500, 15 times 30 is 450, 15 times 5 is 75, and when you add this it is 2025. So instead of just multiplying 15 with directly 135, you can divide it in terms this way, and you can distribute the value, and then you add up the multiplication product, you will get the exact same answer. So similarly it's done this way. Okay, so this is one of the application in which you people have learned the multiplication of 3-digit to 2-digit multiplication of big whole numbers. This is actually the distributive property being used. Fifth is the existence of identity. Identity over here, identity means that if you multiply any whole number with a number, okay, and you get the same identity or you get the same number, okay, as a product. For example, if you multiply 9 with 1, your answer is 9, or you multiply 1 with 9, your answer is 9. Okay, in both the cases 9 times 1 or 1 times 9 is same. So over here we can say that 1 is such a number by which if you multiply any given number, then the result obtained will be the same number. 1 gets multiplied with 9 and the result obtained is 9. So 1 is that identity, or we say the multiplicative identity for the whole number. Okay, so multiplicative identity is 1. That means when you multiply any number with 1, you will get the same exact number. So therefore identity element for multiplication is 1. Next is multiplicative inverse. Inverse means upside down, like x times 1 by x upside down, that is the inverse. When you multiply a number with its inverse, the value obtained is always 1. Okay, so but 1 by x is a whole number only when x becomes equal to 1. So when x is whole number, x is equal to 1, then only this fraction becomes equal to 1. And for other values of whole number like x being equal to some other values like 2, 3, 4, 5, 6, 1 by 2 or 1 by 3, 1 by 4, all these fractions are not a whole number. So here for any whole number, if x is not equal to 1, then its multiplicative inverse will not exist. So if x is equal to 1, then only the fraction remains whole number. If x is equal to 2 or 3 or 4 or any other numbers, then that fraction will remain as a fraction but not a whole number. So that's why here it's mentioned that multiplicative inverse does not exist if it is not equal to 1. So if it is only equal to 1, then only the multiplicative inverse will exist. So here 1 by 1 times 1 by 1 is equal to 1, and 1 by 1 times 1 is also equal to 1. Therefore multiplicative inverse of 1 is 1 by 1, that is 1 itself. Alright, I hope it's clear. Next we have the cancellation law of multiplication. Here x times y is equal to x times z, where x and x can be cancelled, saying that y will be equal to z. So here the example is taken, 3 times a and 3 times b are equal, where 3 and 3 can be cancelled with the help of cancellation law. So a will be equal to b. Similarly, m times 7 and n times 7 is taken, where 7 and 7 can be cancelled. So m will be equal to n. So this is the cancellation law of multiplication.